Military technology has always been at the forefront of human innovation, driving advancements that not only shape the battlefield, but also trickle down into civilian life. In a world defined by rapid technological evolution, the defense sector is no exception. Emerging technologies in artificial intelligence, robotics, quantum computing, and biotechnology are redefining what warfare will look like in the future. Today, we'll explore some of the most groundbreaking developments that could shape military technology over the next few decades and revolutionize how wars are fought and won. First, let's start by looking at autonomous weapons systems and AI integration, one of the most pressing and debated topics in future military tech. Autonomous weapons and artificial intelligence. The potential of artificial intelligence, AI, in military applications is staggering. As AI technologies become more advanced, their ability to assist in or independently carry out combat operations is becoming a reality. The idea of fully autonomous weapons, systems that can select and engage targets without human intervention, poses both opportunities and challenges. On one hand, autonomous systems offer significant advantages. For instance, drones equipped with AI can already carry out complex missions like surveillance, reconnaissance, and targeted strikes with unprecedented efficiency. Swarm technology, which enables coordinated action by multiple drones or robots, can overwhelm enemy defenses. These swarms operate with distributed intelligence, allowing them to adapt in real time to battlefield conditions. AI can also improve decision-making. Imagine AI-driven battle simulations that can predict outcomes based on real-time data, or virtual command systems that assist human generals in making high-stakes decisions during combat. Machine learning algorithms could predict enemy movements, detect hidden threats, and suggest optimal countermeasures. This would result in faster response times and more precise execution of military operations. However, the idea of autonomous weapons raises ethical and legal concerns. Who is responsible if an autonomous drone malfunctions or makes a poor decision? How do we ensure that these systems are programmed with the necessary checks and balances to avoid unintended escalations? International bodies and military organizations will need to develop strict frameworks and governance around these technologies. But the potential is undeniable. Quantum computing and cybersecurity. Quantum computing is another technological frontier that holds immense promise and significant risks for future military applications. While still in its early stages, quantum computers can perform complex calculations at speeds far beyond those of traditional computers. This opens new possibilities for code breaking, encryption, and cybersecurity. Currently, most military communication relies on encryption to keep sensitive data safe. However, quantum computers could potentially crack even the most advanced encryption in minutes. This capability would revolutionize cyber warfare. Imagine a military force that could instantly decrypt the enemy's most secure communications and systems. This would render traditional cybersecurity measures obsolete, and protecting classified information would become a much more complex challenge. On the flip side, militaries are already working on quantum-resistant encryption methods that could withstand such attacks. Quantum key distribution, for example, offers a method of transmitting secure communications by harnessing the principles of quantum mechanics. This would make eavesdropping nearly impossible, as any attempt to intercept the quantum signal would disturb it and alert both parties to the breach. Quantum computers could also revolutionize logistics, simulation, and data processing in the military. Vast amounts of data could be processed in real time to simulate combat scenarios, predict logistical bottlenecks, and optimize resource allocation. The ability to model multiple variables simultaneously would make military planning faster and more accurate than ever before. Directed energy weapons. Another area of significant interest is directed energy weapons, DEDs. These weapons utilize focused energy in the form of lasers, microwaves, or particle beams to target and destroy objects. Directed energy weapons offer several advantages over traditional kinetic weapons, such as bullets or missiles. First, they operate at the speed of light, making them ideal for countering fast-moving targets like missiles or drones. A laser weapon could target and neutralize an incoming threat almost instantaneously. Second, DEBUs can be highly accurate, reducing collateral damage. A laser strike can be focused on a single point, allowing for precision targeting of enemy equipment or munitions without affecting surrounding areas. These weapons are also cost-effective in the long run, Once installed, the cost of firing a laser weapon is significantly lower than traditional ammunition, since it only requires electrical power. For example, the US Navy has already tested laser systems on ships to counter small boats and drones, demonstrating that such technology is not far off from wider deployment. However, directed energy weapons still face significant technical challenges. The amount of power needed to generate and sustain a high-energy laser beam capable of destroying a missile is immense. Maintaining such systems in the harsh conditions of the battlefield is also a challenge. Nonetheless, advances in energy storage and beam-focusing technologies could bring DEWs to the forefront of future military arsenals. Hypersonic missiles. In recent years, hypersonic missile technology has captured the attention of military powers worldwide. Hypersonic missiles can travel at speeds of Mach 5 or higher, more than 5 times the speed of sound, making them incredibly difficult to detect and intercept. These missiles combine speed with maneuverability, allowing them to evade missile defense systems and strike targets with precision. There are 2 primary types of hypersonic weapons: hypersonic glide vehicles, HGVs, and hypersonic cruise missiles, HCMs. HGVs are launched on a rocket before gliding through the atmosphere at high speeds, while HCMs use air-breathing engines to achieve hypersonic velocities during flight. Hypersonic technology represents a significant shift in the balance of power, as it could render existing missile defense systems ineffective. A hypersonic missile could travel across continents in under an hour, giving adversaries little time to react. This creates a more dangerous environment for international security, as nations may feel pressured to act preemptively in the face of such weapons. Countries like the United States, Russia, and China are investing heavily in hypersonic programs. While there are still challenges to overcome, such as improving guidance systems and material durability at high speeds, it's clear that hypersonic weapons will play a significant role in future military conflicts. Biotechnology and human augmentation. As science continues to push the boundaries of what is possible, biotechnology is becoming an increasingly important part of military innovation. Advances in genetic engineering, neurotechnology, and bioenhancement could transform soldiers into highly capable, augmented warriors. Consider the possibilities of genetic modification. Soldiers could be engineered for increased endurance, strength, and resistance to disease. In a battlefield environment where exposure to biological or chemical agents is a risk, enhanced immunity could save lives and increase operational efficiency. Moreover, biotechnology might allow soldiers to heal faster from injuries or even regenerate damaged tissues. Exoskeletons are another area of interest. Powered exoskeletons could enable soldiers to carry heavier loads, run faster, and endure harsh conditions for longer periods of time. These systems are already being tested in militaries around the world, with applications ranging from logistics and construction to combat. Neural enhancements and brain-computer interfaces, BCIs, are perhaps the most futuristic of these developments. BCIs could allow soldiers to control drones or other robotic systems with their minds, or even communicate telepathically through brainwave signals. The fusion of human intelligence with machine capability could lead to soldiers who are not only physically superior, but also mentally connected to the broader network of military systems. However, the ethical implications of human augmentation are vast. The prospect of genetically modified soldiers or brain-augmented humans raises significant moral questions. Where do we draw the line between enhancement and dehumanization? These concerns will need to be carefully navigated as biotechnology becomes more integrated into military strategy. Space warfare. The final frontier of military technology may very well be outer space. As countries continue to develop their space capabilities, the potential for conflicts beyond Earth's atmosphere is becoming more apparent. Space has already been militarized to some degree, with satellites being used for communication, surveillance, and navigation. However, future warfare could see direct military engagements in space. Anti-satellite weapons, ASATs, are already in development, with the ability to disable or destroy enemy satellites. Since many modern military operations rely on satellite technology, the ability to neutralize an adversary's space-based infrastructure could have crippling effects on their capabilities. Without GPS, for example, navigation and missile guidance systems would be severely hampered. In addition to ASATs, space-based weapons platforms are being considered. These could range from missile launch systems in orbit to space-based lasers capable of targeting both ground and space assets. The concept of space-based missile defense systems is also being explored as a way to intercept enemy missiles before they even re-enter Earth's atmosphere. While space warfare remains largely theoretical, the groundwork is being laid for future conflicts in this domain. As more nations develop their space programs, the need for international treaties and regulations governing space warfare will become increasingly important. Conclusion. The military technology of the future promises to reshape the way wars are fought. Autonomous weapons, AI, quantum computing, directed energy weapons, hypersonic missiles, biotechnology, and space warfare are just a few examples of the advancements on the horizon. Each of these technologies carries with it the potential to revolutionize the battlefield, creating both opportunities and challenges for nations around the world. As these technologies develop, it will be crucial for governments, international organizations, and military leaders to address the ethical, legal, and strategic implications they bring. The next few decades will see rapid advancements in military capabilities, but they will also require careful consideration of the consequences. One thing is clear: the future of warfare will look very different from the battles of the past. Whether these advancements lead to a more secure world or a more dangerous one will depend on how they are implemented, regulated, and controlled. For now, we stand on the brink of a new era in defense, one defined by technologies that were once the realm of science fiction, but are now becoming a reality. The military of the future is closer than we think, and the possibilities are both exciting and daunting.